I'm going to pick up from where we left off here, Algebra 2 students, on this one where we're finding the polynomial which has the following zeros. What I mentioned was that if one zero is a 2 and the other zero is a 2i, we must have a third zero of negative 2i, because imaginary zeros, they come in pairs. So for example, if you go back here, and let's say the b squared minus 4ac were negative 16, say, then from this we'll be getting the square root of negative 16, which would be a positive or negative 4i. So that sometimes they might try to trick you by just showing you one imaginary zero, but you should know that if there's one, there's going to be another, which is the complex conjugate of it. So we're looking at these three zeros now. And I'm just going to go ahead and work this out with you with the foiling. It's going to be x times x, which gives us x squared. And we have x times positive 2i, which would be plus 2ix. We're done with the x. Now let's use the negative 2i. Negative 2i times everything in here, first of all, times x. That would give us a negative 2ix. You can see what's going to happen with these two. Positive 2ix and negative 2ix. And finally, negative 2i times a positive 2i. That would give us negative times positive would be a negative 4i squared. Negative 2 times 2 is negative 4, and I times I is I squared. So look with me as we cancel these out. And I squared is what again? I'm sure somebody said it or shouted it. Negative 1. Negative 1 times negative 4 will leave us x squared plus 4. And now we take this binomial and we multiply it by the x minus 2. I'm going to do it right here. X minus 2 times x squared plus 4. So I'm going to take the x and multiply everything in here by it. So x times x squared, that would give me an x cubed. X times 4, that would give me a 4x. And now I'm done with the x. I'm going to multiply the negative 2 by everything in here. So negative 2 times x squared, that gives me negative 2x squared. And finally, negative 2 times positive 4 is a negative 8. Okay? Alright, so no like terms to put together. This is going to be the polynomial resulting from these three roots, 2, 2i, and the one we had to supply, negative 2i. So I can write it like this. Maybe over here. F of x. I'm going to write it in standard form now. It's going to be equal to x cubed minus 2x squared plus 4x and then minus 8. Okay. Notice the degree is 3 here. Why? Because we have 1, 2, 3 zeros. If the degree were 5, then we'd have 5 zeros. 2 more zeros than we have here. If the degree were 7, we'd have 7 zeros. Okay? So that takes us into polynomials and the zeros. And sometimes you just have to be very, very painstaking, very determined to just multiply these together. But remember, when you have imaginary zeros, just do the imaginary factors first. This one times this, and then when you're done, you can do the real ones. Okay, how about something else? Solve each polynomial by factoring. Let's take this one here. Solve. What does it mean by solve? You want to find the x values for which this is 0. So the first thing to do is to factor. Greatest common factor. Take a look at this. This and this. Obviously, we can divide this by 4 and this by 4, but there's more. There's x. So I'm going to factor out a 4x, and that's going to leave me x squared minus 4. And since I'm solving it, I want to find the x values that would make that 0. But you look, you see we can factor again. You see how so? Well, we've got one common factor out, which is 4x, but x squared minus 4 is factorable into two binomials, which would be x plus 2, and what's the other one? X minus 2. Sure, somebody said it. Okay. You can look maybe from a mile away and see what the three zeros will be. This will be 0 when x is negative 2. This will be 0 when x is positive 2. And when will this be 0? When x is 0. Because for 4x to be 0, since 4 is not 0, x must be 0 because 4 times 0 will give us 0. So this will be our three factors here, three zeros rather. X equals 0. X equals positive 2. And x equals negative 2. We're going to solve this one also by factoring, and you look at this, you say, how can we factor this again? This is the sum of cubes. Sum of cubes. So here's a quick review. I think I did it with you this way. Well, yeah, let me go back and do it this way. U cubed plus v cubed. It's got two factors. One of them, since it's plus here, it's going to be the u plus the v. That's the binomial. And then anybody remembers what the trinomial will be? I trust you do. It's going to be this, whatever is in here, squared. And that makes sense because u squared plus u would give us back u cubed. If this is a positive, then this would be negative. And it's going to be the product of these. It should be u times v. I remember having this one student who would say, you or me? U times v. And then finally, the last term is a plus this term squared. So it's v squared. Okay? So those would be the two factors, the binomial here and the trinomial. So let's take it over on the other side. I need some more room to show you. So I'm going to take this now and factor it. The x cubed plus 8. Here we go. Pick another page. X cubed plus 8. We want to solve this by factoring, and again to solve it you want to find the x values that would make it 0. So using the sum of cube factoring, let's write it this way. X cubed plus what cubed would be 8? You said it, 2. Okay, wanted that to be 0. So here comes the factors. The binomial will go there and the trinomial will go here. So it's going to be this one squared. That would be the u squared. I'm sorry. First one should just have the binomial in it, x plus 2. Now here comes the trinomial. It's going to be this one squared, which would be x squared, minus the product would be 2x, 2 times x, and plus this one squared, which would be 2 squared. It's going to be 0 for us to solve it. So, what do we have? We have x plus 2 in one parenthesis, and then we have x squared minus 2x plus 4 equals 0. So we have 1, 0 right out of the gate here. X is equal to negative 2. That would be 1, 0. And this one seemed like it's factorable, but it's not. Usually it's not. Because if we find two numbers which when we multiply together we get a positive 4, such that when we add them we get a negative 2, we can try. Since it's positive 4, then the two numbers have to have the same sign. How about positive 2 times positive 2? That would be positive 4, alright. but positive 2 plus positive 2 will not be negative 2x in here. What else can we do? Well, you could try negative 2 and a positive 2, but that would give us a positive 4. You could try negative 2 and negative 2. That would work for this, but that would give us a negative 4x in here. So what to do? Well, we're not stuck. The quadratic formula is one that I call the Jesus formula because it solves every quadratic equation, even if it's not factorable like this one. So let's go ahead and solve this one. X squared minus 2x plus 4 using the quadratic formula. What x value would make that 0? Well, let's use a formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over what? 2a. So what are the a, b, and c? A is 1, b is what? Negative 2, and c is 4. So here I go. For b, I'm going to put negative 2. Under the square root here, I'm going to put negative 2. That is squared. Minus 4 times a is 1, and c is 4. Copy to 4. All over what? 2a, which is 2 times 1. Here we go. Minus negative 2 is going to be a positive 2. Plus or minus, I've got my minus here. This is going to be the square root. Negative 2 squared would be 4. And negative 4 times 1 is negative 4. Negative 4 times a positive 4 is going to be a negative 16. All over 2 times 1 is 2. I'm going to take it down here now. It's going to be 2 on the outside, plus or minus. Inside here is 4 minus 16. That's going to be a negative 12. All over 2. And this is going to be imaginary because b squared minus 4ac is negative. You see it? Yes, so this is going to be imaginary. We're going to have two imaginary roots. And to 12, we could simplify. So how do we simplify that? Think with me. Two numbers which when you multiply them together, you get 12, such that one is a perfect square. Perfect square is a number like 4, 9, 16, 25. It's got a whole number square root. So 12 is the same as what? 4 times 3. Okay? 4 is a perfect square. That's what we're looking for. 4 times 3. So this we can write as 2 plus or minus square root of 4 times 3 all over 2. Square root of 4, we know what that is, but I forgot something, the negative here. That negative would have to be like this, and this we know is going to be I. So here comes the answer. It's going to be equal to 2 plus or minus square root of 4 is 2. I'm going to put the I next. Square root of negative 1 is I. And then 3 comes afterwards, like that, square root of 3. And this is all over 2. Okay? These would be the answers. Notice we have an imaginary answer here, and there's a positive version of it and a negative version of it. As I mentioned, imaginary solutions or zeros come in pairs. And don't be intimidated by this. Some of you might be rattled right here. 12 is nothing more than 4 times 3. And I broke it like that because I wanted to find two factors of 12 such that one is a perfect square. I got it. Okay, if it were, let's say, the square root of negative 7, I just have to leave it like that. As the square root of 7. Because 7 does not break. We can't break it into factors.